The journey for extraterrestrial life has inspired numerous science fiction stories and has even fueled missions by NASA. Perhaps one of the most enchanting places in this search is Europa, a moon of Jupiter, which many believe could hold vital information. Bill Nye, the prominent science communicator, is among those who advocate for further exploration of Europa, believing that this celestial body might be fundamental to unraveling the secrets of life beyond Earth. NASA's Pioneer 1 spacecraft, launched in 1977, made a groundbreaking discovery beyond our solar system. This discovery has drawn the attention of some of the brightest minds today, including Bill Nye. What Pioneer 1 found was ionized gas particles actively colliding and interacting beyond the heliosphere, the bubble-like region created by the solar wind. These readings provided crucial insights into what conditions might be like beyond our planetary system. Could these be indicators of extraterrestrial life? This question has captured the imagination of scientists and space enthusiasts alike. Bill Nye has long been a leading figure in the search for extraterrestrial life. His passion for the unknown is evident in his interviews and talks, where he frequently emphasizes the importance of space exploration. The discovery made by Pioneer 1 has further fueled this enthusiasm, offering new data that might finally answer the age-old question: are we alone in the universe? To understand why this discovery is so significant, it's essential to look back at the beginning of space exploration and the events leading up to the launch of Pioneer 1. During the 1970s, NASA had recently achieved an incredible milestone by sending humans to the moon. This achievement sparked widespread excitement within the scientific community, and plans were soon in motion to explore much farther into space. NASA's next objective was to study the outer planets of the solar system. However, sending humans on such a mission was not yet feasible. The vast distances and the limitations of 1970s technology made it necessary to rely on robotic spacecraft for these ambitious explorations. At the time, the Cold War was in full swing, and the US was engaged in fierce competition with the Soviet Union. This rivalry extended into space, where both nations were striving to demonstrate their technological superiority. The Soviets had made the first major strides in space exploration, launching the first artificial satellite in 1957 and sending the first human, Yuri Gagarin, into space in 1961. However, the US caught up with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This victory was a turning point in the space race. However, the US knew it couldn't rest on its laurels. The competition with the Soviet Union continued to drive NASA's ambitions to maintain its lead in space exploration. NASA aimed to go beyond the moon, and the new objective was to explore the outer planets. The agency began developing spacecraft capable of traveling deep into space. One of NASA's first attempts was the Pioneer 10 spacecraft, launched in 1972. It became the first to fly by Jupiter and send back images. Pioneer 11 followed the next year, also heading toward the outer planets. However, NASA needed a more advanced spacecraft that could capture detailed images and data from not only Jupiter but also Saturn, Uranus, and Neptune. This led to the development of the Voyager program. The plan was ambitious: to use a rare planetary alignment known as the Grand Tour to slingshot the spacecraft from one planet to another using gravitational forces. This alignment, occurring only once every 175 years, would allow NASA to study all the outer planets in a single mission, saving both time and money. To achieve this, NASA built two Voyager spacecraft. Voyager 1 was designed to take a shorter path, visiting Jupiter and Saturn, while Voyager 2 would follow a longer route to reach Uranus and Neptune. On August 20, 1977, Voyager 2 was launched, followed by Voyager 1 on September 5 of the same year. These twin spacecraft would go on to make some of the most astonishing discoveries in the history of space exploration. Voyager 1 began capturing images of Jupiter on January 30, 1979. These images revealed details of the gas giant that had never been seen before, including the Great Red Spot, a massive storm that had been raging for centuries. But Voyager 1's mission didn't end there. After completing its flyby of Jupiter, the spacecraft continued to Saturn, where it sent back even more remarkable data. The discoveries made by Voyager 1, particularly its detection of ionized gas particles outside the solar system, have had a profound impact on our understanding of the universe. As the Voyager missions continue to send data from the farthest reaches of space, the search for extraterrestrial life remains as relevant as ever. Bill Nye and other scientists believe that exploring places like Europa, with its subsurface ocean, could lead to the next major breakthrough. What we learn from these missions could forever change our understanding of life in the universe. At regular intervals, Voyager 1 captured images and combined them to create a color stop-motion video. Using this technique, Voyager 1 was able to send back a film showing 10 rotations of the largest gas giant. By February 10, Voyager 1 had moved into the planet's moon system, sending back footage of the moons orbiting the gas giant. It soon discovered a thin ring of dust and ice surrounding the planet, previously invisible from a distance. This revelation showed that Saturn was not the only planet surrounded by rings. The ring was less than 30 meters in diameter, surprising scientists with how little they had previously known about the planet. By April 5 of that year, Voyager 1 had its closest encounter with a giant planet, separated by a mere 174,000 miles. During this close pass, the spacecraft encountered several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The images it sent back provided groundbreaking insights into these celestial bodies. Priceless bits of knowledge into the unusual universes of these moons, some of which shared little in common with our moon, were subsequently referred to as the Galilean moons, named after the astronomer Galileo Galilei, who discovered them in the 17th century using his telescope. One of the smaller moons observed by Voyager 1 was Amalthea, a reddish, irregularly shaped satellite with a peculiar surface design. Images sent by the spacecraft showed that it was composed of ice and silicate materials. The surface appeared red due to the presence of organic material, and its strangely twisted surface indicated that it had experienced little internal activity compared to other moons. Io was considered the most geologically active body in the solar system, with numerous active volcanoes and lava flows visible on its surface. These volcanic activities were triggered by tidal heating caused by Jupiter's immense gravity, making the moon resemble a volcanic hellscape rather than a typical moon. Europa was particularly remarkable for its smooth, icy surface, which covered a vast expanse of water beneath. Many experts believe that life could potentially thrive beneath the ice, making the moon a prime candidate for extraterrestrial life. A few craters were found on the icy surface, indicating past collisions with asteroids and smaller comets. Following these discoveries were images of what appeared to be the largest moon in the solar system, Ganymede. This moon was so massive that it surpassed the size of the planet Mercury. It was large enough to have its own magnetic field, and images revealed that its surface was largely covered in rock and ice. Ganymede's potentially complex geological history continues to astonish scientists to this day, and it likely contains a liquid core deep within, responsible for its strong magnetic field. Another significant moon observed by the spacecraft was Callisto, the second largest of Jupiter's moons. Its heavily cratered surface suggested a history of frequent impacts with asteroids, and it also showed an absence of geological activity. Like Europa, it is believed to have an ocean beneath its surface, making it another possible candidate for extraterrestrial life. 2 new moons were discovered by the spacecraft and named Thebe and Métis. Images showed that they were both small and irregularly shaped, orbiting much closer to Jupiter than the other satellites. It is fascinating to note that the planet itself, along with the moons observed by the spacecraft, were named after famous mythological figures. The giant planet was named after the renowned Greco-Roman god of thunder, and its moons were named after those who had close encounters with him. After the spacecraft's encounter with Jupiter, a course correction was made to prevent it from spiraling out of control like the natural satellites. This adjustment was in preparation for its journey towards Saturn. Around 6 months later, in October of that year, another course correction was made to avoid a potential collision with Titan, one of Saturn's moons. The encounter with Saturn was just as spectacular as the one with Jupiter. The spacecraft discovered 5 new moons, a ring system with thousands of particle groups, transient clouds composed of particles called spokes, and a previously unseen ring. It was also found that some moons were responsible for maintaining the well-defined structure of Saturn's rings. It is likely due to these moons that the planet's rings appear so pristine. In the following years, Voyager 1 captured stunning photographs of Saturn's moons, including Titan, Mimas, Enceladus, Tethys, Dione and Rhea. The images revealed that these moons were largely composed of ice, with potential subsurface oceans, increasing the possibilities of extraterrestrial life flourishing beyond Earth. Yet, those weren't the only discoveries that amazed NASA scientists. One of the most striking revelations was about Mimas, a relatively small moon. It had a massive impact crater so large that it was named Herschel. What made it so intriguing was that it caused Mimas to resemble the Death Star from the famous sci-fi series Star Wars. This fascinating feature indicated extremely low geological activity and a massive past impact with an asteroid. Other moons observed by the spacecraft were mostly composed of ice, each with unique characteristics. However, perhaps the most captivating of Saturn's moons seen by Voyager 1 was Titan. The spacecraft conducted a close flyby on November 12, at a distance of under 3,000 miles. The images revealed a dense atmosphere that completely obscured the surface. The atmosphere was primarily composed of nitrogen, with an atmospheric pressure equivalent to that at sea level on Earth, though at a chilling -300 degrees Fahrenheit. Features on Titan suggested that it could be the only body in the solar system apart from Earth, where liquid might exist on the surface. The chemical reactions necessary for the formation of life appeared to be present, with strong evidence of large hydrocarbons essential for life to emerge. Voyager 1's closest approach to Saturn occurred on November 12, at a distance of under 8,000 miles from the planet. By 1989, all planetary encounters for both Voyager spacecraft were complete, having explored all 4 gas giants as planned. However, both spacecraft remained operational and were officially declared part of the Voyager interstellar mission, a program that began on January 1, 1990. The new objective was to travel beyond the outer planets of the solar system and, if possible, beyond the heliosphere, the protective bubble surrounding our solar system. More specifically, the mission aimed to gather data on the region of space influenced by Earth's magnetic and solar fields, as well as the interstellar medium. On February 17, 1998, Voyager 1 became the most distant human-made object in existence, surpassing Pioneer 10 at nearly 70 astronomical units from the Sun. By September 2017, 45 years after its launch, the spacecraft was still functioning, transmitting data to NASA's Deep Space Network. It was astonishing to scientists that its onboard instruments, such as the plasma wave instrument and magnetometer, were still operational after more than 4 decades in space. As Voyager 1 and Voyager 2 ventured farther from the Sun, their missions took on new significance. Voyager 1 entered interstellar space in August 2012, marking humanity's first journey into this unexplored region. This achievement provided scientists with an unprecedented opportunity to study space conditions beyond the heliosphere. The spacecraft's data has been instrumental in understanding cosmic rays, magnetic fields, and plasma interactions in interstellar space. Voyager 2, meanwhile, continued its mission to explore the outer edges of the solar system and eventually entered interstellar space in November 2018. Its trajectory provided valuable comparisons with Voyager 1's data, further enhancing our understanding of the solar system's boundaries. Both spacecraft carry a golden record, containing sounds and images meant to represent the diversity of life and culture on Earth, a message to any potential extraterrestrial civilizations, expressing humanity's desire to connect with the universe. As the Voyagers continue their journey, they also contribute to the broader field of astronomy by observing phenomena such as the interstellar medium, the local interstellar cloud, and the interactions between the solar wind and the cosmic environment. Their discoveries have provided insights into the structure of the heliosphere and the nature of the interstellar magnetic field. The data from both spacecraft remain crucial for future interstellar missions. As technology advances, scientists and engineers are studying the Voyager's performance to develop new spacecraft capable of traveling even farther into space. This includes potential missions to explore nearby star systems or examine the limits of the Milky Way galaxy. The legacy of the Voyager missions lies not only in their close-up discoveries but also in their role as pioneers of humanity's deeper exploration of the universe.